We're going to talk about different types of numbers today. So we're kind of going to make what I call a little family tree of numbers, which I'll explain in detail a little bit more. So any number at all that we work with in here is called a real number because it really exists. So we're just going to make a note, like all numbers. There are things called imaginary numbers, but we don't deal with them in this class. If you took Algebra 2, that's where you would learn about imaginary numbers. Within the real family, we break off into two sections. We could have irrational and rational. Now, irrational numbers are, we refer to them as the more ugly numbers, numbers that don't have an ending but don't have a pattern either. So for example, pi. In the calculator, if you type pi, you'll get 3.14 ... It goes on forever. So even though it ends at the end of your calculator screen, it's really going on forever. It's just your calculator can't display all the numbers because it's never ending. You could make up an irrational like 2.314 ... So these numbers are not repeating. There's no pattern. And the ... means it goes on forever. So it would be irrational. And then the other type of irrational number we see are non-perfect square roots. So like the square root of 15. When I type that in my calculator, I get a really long decimal. That means it's irrational. That decimal is not ending and it's never going to have a pattern. So the roots are pretty easy. If they come out to a whole number, they go in the rational, and if they don't, they go in the irrational column. So rational numbers, there's actually a lot more. They could be whole numbers like 6. Any fraction is a rational number. In fact, rational means that the number can be written as a fraction. Repeating decimals or patterns like 1.33 ... that is a rational. Even though it has the ... it has a pattern, it's repeating. The reason that's the case is if we take the fraction 1/3. If you type 1 divided by 3 in your calculator, it says 0.333 repeating. So repeating decimals are fractions. You could even have a square root depending on what that square root is, like the square root of 16. If we type square root of 16 in our calculator, we're going to get a whole number 4. Since 4 has an ending, we actually put that in the rational. So what you don't want to do is just automatically see a square root sign and just decide, oh, it's got to be irrational. You actually have to see what the value of that root is before you make a decision. In the rational family, we have a couple more specific numbers. The first kind are what we call integers. Now, even though you won't be tested on the definition of integers, you'll hear the teachers use that word a lot. I'll say, no, you should get an integer for your answer. That means you should get a whole number. So integers are just whole numbers. They can be negative, they can be 0, they can be positive. Within the integer family, we have whole numbers. Whole numbers are just from 0 to infinity. And then within the whole number family, we have naturals. Those are pretty much the same thing except no 0 for natural numbers. So the way we read this chart is we read it from bottom up. If, like, say, this bubble right here, the whole number bubble, is underneath integers, rational, and reals. So whole numbers are also integers, they're also rationals, they're also reals because they're underneath of them. So we would say all integers are rationals, but not all rationals are integers. You cannot read it going downwards. All irrationals are reals, but not all reals are irrational. No whole numbers are irrational. No integers are irrational. All naturals are also integers. All naturals are also rational. So that's how we kind of want to read the chart. So you'll see on your homework tonight that you have some true and false questions that you have to answer, and use this chart to help you determine the answer.